Good afternoon, Scott here, known as Cantaloupe to some online, bringing a video to you today on a subject that's interesting to me. It might be of interest to you or someone you know about. And that subject is preservatives. And I'm going to qualify my knowledge on the subject as usual with being officially a layperson on the subject of preservatives. I don't have any official training or degrees in that subject, but I do know some things about how it works because of classes I have taken that are connected to it and my personal experience in the food industry. I guess I should mention that I have culinary training and food safety training. So, on that note, preservatives are an interesting thing because without them, food would not last very long at all. So, it's helpful to understand how they work. If you ever need to create a preservative or use one, it's very important to have an understanding of the principles of how to make food last longer. And the final point of this video should be interesting to even people who aren't interested in preservatives necessarily. So, with that said, all preservatives operate on a similar idea that things that can grow in your food, things that would normally decompose your food, if it was something that, for example, meat that was part of an animal that died and it has to decompose. Well, there's a natural process, of course, and same with fruit or any kind of vegetable or organic material goes through a similar process whereby it's consumed by microorganisms. Mostly, that's what happens. So, how do we preserve food? Well, we prevent microorganisms or bacteria from reproducing. Basically, it's all you really got to do. That's the number one and only objective in preserving your food, is to keep things that would normally change its chemical structure or decompose it in some way from reproducing or getting to it. So how do you do that? Well, there's a lot of different ways. Of course, there's the refrigeration's an obvious one. You can slow down the process. Anything that is refrigerated takes longer. It doesn't stop decomposition or spoilage, but what it does do is it takes much, much longer. It slows down all biological processes. Biology and temperature are very closely related. Not to digress too far, but for example, reptiles they're cold-blooded by definition. Life does not necessarily need to be warm-blooded like mammals. Humans are mammals. We are warm-blooded. All mammals are warm-blooded it's a defining characteristic. But most life, the vast majority of bacterial life and other kinds of life, have no inbuilt heaters. They don't have it, and that means that when it gets cold, like in a refrigerator, everything slows down. Their whole process slows down. Reproduction may almost be prevented, but not quite. So that's not really preservatives, though. So temperature is one thing. Now, what about stuff that's not in the refrigerator? We call these either perishable or non-perishable items. Perishable items are obviously, dairy products, eggs and meat, even vegetables. Anything that can, if it's just left out at room temperature, it will spoil, and pretty quickly. We call these perishable. So what happens, and how do you keep that from happening? So these organisms, microorganisms, and I learned about this in college biology. There's something called a selectively permeable membrane, which is a membrane around cells or cellular cell-like organelles or organs that allows fluid, usually water, to pass through it selectively, or other substances. Now, that's kind of technical in a biological terminology sort of way, but what it means for bacteria is that you have a disproportionate concentration, usually of solutions of chemicals on one side of the membrane and on the other side of the membrane. So you have water, obviously, is fairly neutral. All life depends on water. It enjoys reproducing near and around and in water. So the foods we eat are obviously chock full of water, usually, unless they're dehydrated. So that is another form of preserving foods. There's tools you can use to dry food or make jerky or breadstuffs is commonly preserved by way of baking it, and then it is dry. which prevents or slows the bacterial or microorganisms from reproducing. So uh, the most common way now in recent, I say recent, in the past, hundreds of years or maybe thousands of years, humans have employed a very simple and easy form of chemical preservatives. Now, what would that be? Salt, right? Okay, now most people have heard of this. If you have a salty food, why do we salt our food? Well, for flavor, of course, but more commonly, and much more commonly, we salt it to preserve it. Now, how does that work? Why does it preserve it? Why can salted foods sit out when, if you didn't salt it, it would spoil within a day or two? Because it does. Many foods, eggs, meat, dairy, it'll spoil almost immediately. Now, this selectively permeable membrane of microorganisms, when you have what's called a solution of salt, for example, it doesn't have to be salt, it can be sugar. Sugar is also a preservative on one side of that membrane, and you have not salty water or sweet water inside the organism, or vice versa. Either way, actually, you create what's called a tension. There's the fluid wants to go one way, but the selectively permeable membrane forms a tension one direction or the other, which causes the organism or organelle to explode. It's kind of graphic, but that's how it does it. So what you end up with on a large scale, you have obviously many bacteria potentially reproducing, coming in contact with exposed food at room temperature. If it's salty or sweet, the moment, almost instantly, when those bacteria come in contact with your food, they experience death because of the selectively permeable membrane. They explode, they cannot reproduce. And the net effect of having salty or sweet food or preserved with some other chemical substance, and we have tons and tons of factory-made chemicals. I'm not going to get into all that, but it's the same principle. There's a threshold. You find that there's a very specific threshold of concentration or solution beyond which nothing grows. No, I mean, common bacteria, common microorganism. I mean, maybe there's some super bug that might grow in it, but you're not going to normally run into that. So when you reach that threshold, when you achieve, and it's not really that much. You don't need a whole lot of salt or sugar to preserve your food, and it's amazing. Now, this is the point that might be interesting to people who aren't super pumped up about the idea or the concept of preservatives. Once you get to that threshold of sweet or salty, you can leave that stuff out virtually forever. And I will stand by any fair scientific test that tries to prove this wrong, because I've observed this myself. If you have, for example, perishable salad dressing, but it's got just enough sodium chloride is salt, common table salt. If it has above that threshold, and most of them do, even if it says for refrigerate after opening, it will sit out forever and stay good. And I know this because I've done this myself. So anyway, something to think about. If you ever find yourself in a situation where you need to keep your food from spoiling, and you invest in a little bit of sugar or salt just to keep for that purpose, it's not a bad idea, because you never know what's going to happen with mass-produced, farm-produced food. Sometimes we in this part of the world, Americans, don't commonly experience disruptions in our food supply or chain of or product chains, but you never know. And historically, it happens all the time. So I wish you the best, and I hope we don't have to personally invest in that kind of thing in preservatives. But if you ever do, now you know how. So thank you. If you have any questions, reach out, whitehotrobot@gmail.com. Thank you.